Alright, we are going to be moving into 11.5 in this video, which is multiplying and dividing rational expressions. You're going to see down below, this image is showing you what we did in the past in chapter X.4 when we were working out of our books. Remember what we were reviewing were multiplying and dividing fractions. We're going to be using those same rules that we used last time, and actually I'm going to be using some of the same PowerPoint slides as last time to help us through this 11.5. So here is the chapter 11.5 actual PowerPoint now. We're going to be using past knowledge on multiplying and dividing fractions to multiply and divide rational function expressions. So we're going to be transferring this information that we had in that chapter X to be doing these rational expressions. And this is an example of the type of problem that we're going to come across. So looking at that, I'm going to actually do that later on in this video. The other thing that we're also going to have to use and continue to apply is the skill that we just learned in the past section. It was simplifying and reducing these rational expressions. We're going to have to apply that to this section as well. So, how to multiply fractions. Remember, this is just a matter of multiplying straight across the top to get the top, multiply straight across the bottom to get the bottom. Biggest thing here is don't forget to reduce common factors on top and bottom. If you ever have some sort of factor that's exactly the same on the top and exactly the same on the bottom, you just simply can reduce them and say that, for example, x plus 2 over x plus 2, that's just equal to 1 over 1. It's just equal to 1. Okay, so reduce these. Yeah? Alright. One thing to keep in mind is that you do not need common denominators. Once again, straight across the top, straight across the bottom, just multiply. And then finally, how to divide fractions. We're going to also be working on that. You're going to see that it syncs up very much with the multiplication because we, don't forget, turn our division of fractions into multiplication of fractions. So we're going to use that catchy phrase, keep, switch, switch. You keep the first rational expression. I should change these this time. So you're going to keep the first rational expression, which we call the dividend. It's the first number, and then switch the division into multiplication, and then we're going to switch the second rational expression, which is called the divisor, into its reciprocal. So just to make note, reciprocal, if you need to write this down, the reciprocal is the numerator and the denominator switched. Okay, you just switch the places of the numerator and denominator. Alright. One thing to keep in mind is if you ever have a mixture where you're doing, when you ever have the same thing going on where a positive and a positive is in the division or multiplication hood, negative and a negative is in the division or multiplication hood, the result is always positive. They get along. But if you ever have a mixture, so you're trying to divide a negative something divided by a positive something, negatives and positives don't get along, you get a negative result. We're going to work out some examples of this. On the first slide we had this problem right here. This is number 18. Alright, so what I would like to say is you're probably going to want to factor completely all of these rational expressions that you have here. So on the top you're going to want to say, can I completely factor this? So this is going back to what we were doing yesterday or in the lesson previous. If you look at 5 and negative 2, there is nothing in common between the two. They don't share any common factors. 24, can I factor 24 completely? So I'm going to rewrite 24. I'm going to do my factor tree down here. I'm going to rewrite this as 2 times 12, break down 12 to 2 times 6, break down 6 to 2 times 3. So you could rewrite this to be the factors 2 times 2 times 2 times 3. So I'm going to do that. Okay, so there that is. Negative 2 is pretty much as prime as it can get. If you wanted to, you could write it as negative 1 times 2. I'm just going to keep it as negative 2. Alright, this one right here, can this be factored completely? And remember, factoring completely is when I want to say, is there any common factor in this 10? Is there any common factor in this 4x? And I want to pull that out if I can. So I'm going to factor tree this right here, I'm going to do 10 and this 4x. 10 would be 2 times 5. Those are both primes, can't go any further. 4 is 4 times x. 4 can be broken up into 2 times 2. I'm going to circle what they have in common. They do have something in common that I could pull out or rip out of both of these trees. I'm going to pull out this 2. So I'm going to put that 2 out front here. And what is left is a 5 from the 10. So if you can kind of visually see this here too, pull out that 2 from a 10, what you have left is 5. So 2 times 5 is 10. Minus, we have that minus. If I rip out a 4x, or sorry, I rip out a 2 from this 4x, look at your factor tree too. If you ripped off that 2, you'd only have 2x remaining. So kind of just make sure that this is what you want. When you distribute that 2 back in, do you get 10 minus 4x? And yes, you do. 2 times 5 is 10. There it is. Minus 2 times 2x is 4x. So there we have it. So now the process of multiplication states this. I can just go ahead and multiply straight across the tops. So this is what I would have on top. I would have 5 minus 2x times 2 times 2 times 2 times 3. Okay, on the bottom, what I'd have is negative 2, okay, times 2, this is a factor in itself now, times 5 minus 2x. Okay, and what I do want you to see is here I am going to pull out that negative 1 and then make this positive. So here I'm going to have negative 1 times 2. Those 2's are exactly alike, they can cancel off. These 2's are exactly alike, they can cancel off. See this 5 minus 2x exactly alike on the bottom? They cancel each other off because they just equal 1 over 1. So basically what I have here is 1 times 1 times 1 times 2 times 3. On the top what I have left is 6. On the bottom I have just this negative 1, negative 1. So here what we have is negative 6 completely simplified. Done. Isn't that remarkable that we went from here to here? Okay, we have simplified this expression, this multiplication problem completely.
Oh, no. Hello, sit. Bang, bang, dead. Good girl. Hey, sit. Hello, sit. Sit. Bang, bang, dead.
I'm also going to do number 24 with you. So what I am going to go ahead and do is say that this is a factor, this is a factor. We're taking 2 times all of this divided by 4 times all of this, and then we have this whole factor chunk down here. What I do want you to notice is this is a prime, can't be factored anymore. X plus 2 is also a prime. If you ever have kind of just an x by itself and then a number by itself, keep in mind that there's nothing in common. You could do your factor tree, but those are both prime numbers in themselves. There's nothing that they share in common. 4, we could factor that a little bit more, so I'm going to go ahead and start doing that. I'm going to write it as 2 times 2 times x minus 2, and then this right here on the bottom, 5 is prime, that doesn't factor anymore. X minus 3 also prime, it doesn't factor anymore. You can try to do your factor tree for that too. This is just 1 times x, this is just negative 1 times 3, nothing in common, so there's nothing that you could pull out. Over here, this 5x minus 15, negative 15, can we factor any of these out? I would have to write this as 5 times x. This would be negative 1 times 15. You would have 5 times 3. Now here we do have something that we can pull out. There's that 5 in both of them. So I'm going to rewrite what I have right here as 5 times, oops, sorry. Yeah, so I pulled out that 5. I pulled out that 5 that's in both 5x and negative 15. And what's left when you pluck that factor of 5 off? You have x remaining. And what you have left when you pluck that 5 off of this tree, the branches leave us with negative 3 times, negative 1 times 3. So what we have is negative 3 left. Okay. So there we have it. If you did distribute that back in, you would get exactly this. So I haven't changed anything about this. I've just separated everything into complete factors. Okay. So now the process for multiplying is, the process for division is to keep, switch, switch. KSS is what we're going to say. So I'm going to keep my first number, my first rational expression, exactly how it is. So there's my dividend. I'm going to be taking this number and keeping it exactly the same. I am going to switch this into multiplication and then also switch this into its reciprocal. And remember, what happens for reciprocal is everything on top would go to the bottom, everything on bottom would go to the top. So what we have is our bottom is now our top, and our bottom, or our top is now our bottom. Okay, so now this is where we would just resort back to multiplying, multiplication rules. This is where you would just go straight across the top. So I'm going to straight across just multiply everything. All my factors are going to go together on the top. All my factors are going to go together on the bottom. Okay, and here is where you're going to want to identify anything that's in common. If there's anything exactly the same on top and bottom, you will cancel them out because 2 over 2 is just 1 over 1. 5, I see a 5 here. 5 over 5 is just 1 over 1. X plus 2, I was thinking, hey, there it is, but they're not exactly the same. This is a minus, this is a plus. I can't cross that out. However, I can cross out this x minus 3, x minus 3. X minus 3 over x minus 3 is just 1 over 1. So what we have left on the top is going to be x plus 2 is left on top. That is that factor on top that was left, and then 2 times x minus 2. Done. Okay, so there is nothing in common on top and bottom. This is as simplified as it can get. And we did our process of division, so it's once again kind of nuts how we went from here to here. All of these skills are going to be building into our project, so don't forget that we're going to be basically applying our math into our science realm and be looking at focal points of satellites, and we're also going to be doing other inverse and direct relationship kinds of problems, which also are very, very present in science. So just keep in mind these skills and keep organized your notes so that you have them all as a resource.